Hey guys, I'll be going over a question over the 2016 AP Physics 1 exam today. So in this question, we're given that a cart is rolling down a ramp with bumps that are equally spaced. So in part A, we're trying to graph the cart's velocity as a function of time as the cart is going across bumps 41 to 44. So we know that the cart will start off with some initial velocity at 41. So let's draw that in. And from the period of 41 to 42, it'll increase linearly as acceleration is constant. However, once the cart hits 42, we would expect a force to act against the cart, lowering its acceleration, which in turn lowers its velocity once the acceleration is below 0. And from bump 42 to 44, we would see the same pattern emerge. Alright, now in part 2 of part A, we are asked to draw a horizontal dashed line through what we would assume is the average velocity of the cart over this period. So by taking the midpoints of all of these lines, we can draw a horizontal dashed line, just like that. Okay, now moving on to part B. Suppose the distance between the bumps is increased but everything else stays the same. Well, the maximum speed of the cart would increase because there's more time for the cart to accelerate between bumps, right? So we just check greater than. And now for part C. With the bumps returned to the original spacing, the track is tilted to a greater ramp angle theta. If we think about this logically, we have the cart, right? And it'll be traveling down a ramp, so its gravitational force will be mg, pointing down this way. We can split this force up into two vectors, one pointing perpendicular to the ramp and one pointing parallel to it. The parallel one is the one we're concerned with, right, in this equation. So this would be mg sine theta, and that is directly proportional to the velocity. So we see that if sine theta increases, then the entire equation increases. So this question is also greater than. Alright, for part D, we're given an equation and a graph, and we want to see if these two are a good match for each other. And it seems that this equation, or this graph, has velocity average plotted as a function of mass. So in part 1 of this question, we're asked if the data is consistent with the student's equation. Well, both sides of the equation are one term, and if any variable besides d is equal to 0, we would assume both sides of the equation should be equal to 0. This means that the line should pass through the origin, but as you can clearly see, it does not. So this is a no. In part 2, another student suggests that the data is consistent with the equation, and the equation could be incorrect for other reasons. Does this equation make physical sense? Well, in part B up here, we found that the maximum speed of the cart should be increasing, which, if we relate it to this equation, would mean an increase in the average velocity. However, we see that the d, which represents distance, is in the denominator here, which means that as d goes up, velocity average goes down. So this also doesn't make sense. Alright, and that was my first video. So if you have any suggestions or comments, please tell me, and I appreciate your feedback. Thank you.